So welcome everyone. This is Maggie Hurwitz, and also we have my colleague Jenna Myers from the Climate Services branch for today's webinar. Thanks for joining, and this is part of a focus on hydroclimate, at least for this year. We'd like to plan some more webinars on various topics related to hydroclimate. So if you're interested in presenting or you know of a good topic, whether it's a regional focus like today's webinar, some new research, or a tool that you think especially users from the Weather Service would be interested in, please contact me. Following the presentations today, there'll be a chance for you to ask questions. So you can use the chat feature in GoToWebinar, or you can use the raising your hand feature, and we'll try to get to your question. So today we're very lucky to have Doug Cluck and Natalie Umflett, who are going to talk about the Missouri River Basin in 2019, which is expanding on a recent report that they wrote. Doug Cluck is the Regional Climate Services Director for Wettest for the Central region of the U.S., and Natalie Umflett is a research scientist at the High Plains Regional Climate Center and the University of Nebraska-Lincoln. So I'll leave it over to Doug Cluck to give us an overview of the Missouri River Basin in 2019.
Hi, everyone. Thanks for joining us today. I'm going to give a fairly fast, as fast as I can go, sort of lead up to all the good stuff that Natalie's going to talk about, and actually the briefing and report that was put together out of the High Plains Regional Climate Center with several different partners. So I'm going to kind of start by putting it all in perspective. This is not the Missouri. This picture here is actually the Platte River, which also flows into the Missouri River. But it's a great picture. It almost looks like you're in someplace in Africa with all that sand and all over the place, which of course is displaced sand from the flooding of last year. So let me just see if this works here. Click. There we go. Out of the National Climate Assessment reports, most recently that came out in the last few years, this large picture of the United States on top is basically showing you the difference between and more or less the trend in terms of precipitation when you compare the most recent 30 years or close to the most recent 30 years. And this does not include, by the way, obviously 2016 to 2019, which would probably show even darker green colors in the upper Midwest for sure. But notice the change in precipitation percentage over that period of time. It's basically gotten wetter over the central part, and especially the north central part of the United States, when you compare those two time periods. In the lower left is another image showing trends in flood magnitude in terms of percentage. The green triangles there, the larger they are, shows the the larger the trend or percentage in decadal change in flood magnitude. So Red River Valley, you see it up there, and some of these other ones down in the lower, I'd say lower Missouri and eastern Kansas and such, and of course the Midwest, mostly are on the uptrend in terms of flood magnitude. And then simply that image on the lower right is the percent increase in heavy precipitation at the 1% threshold across the United States. So places like the Northeast, Midwest, even upper plains, high plains, northern plains, all show the greatest increase in heavy precipitation events. So that's all stuff to kind of keep in mind as we go into this. The other thing also to keep in mind, because we're going to tie this a little bit potentially, even though this is not a study on attribution, that's coming, I think, later this year from a different part of NOAA. But always remember that, and we know this from our everyday work, it's certainly in the Weather Service, the warmer the air holds more water vapor, right? So when you generally have a warmer climate, you generally have more water to work with in the atmosphere through the column, to the troposphere. So that's sort of showing you the almost exponential nature of, as you increase temperature on the bottom, how much more precipitation, or how much more, sorry, moisture you can hold in the water column. Okay, some other observed changes. These are not predictions or anything. This is what has been noted. Northern Great Plains, and this is broken out, by the way, in National Climate Assessment regions. That's why it's broken in the way that it is. Midwest and Northern Great Plains both show pretty strong increases the last few decades in terms of very heavy precipitation. When it rains, it pours is an adage that is carries through certainly to these days. And then up in the upper right, you can see the decadal pattern across the entire U.S., which shows pretty much the same thing we're seeing here in the central part of the U.S. Another interesting factor is when you look at return frequencies, and this shouldn't surprise anybody, when you look at return frequencies, say for the 20-year return precipitation return level, we have seen an increase pretty much across the board, no matter what season it is, across the U.S. Mostly, there's a few places where it's declined in the winter, but I mean, they're very minor in the Northwest. But really, where we're focusing on this kind of central part of the U.S. here, and notice the big increase in the 20-year return frequency of precipitation in the fall. That's an issue for a number of reasons. It's typically not that wet of a season for us. It's usually a season where, for example, in the Missouri Basin, the Corps of Engineers evacuates a lot of water out of their huge reservoirs there. They depend on that season to do that. They don't get that. They kind of go into spring and winter and spring too full, if you will. So it's troublesome to them to see this sort of trend in precipitation. These are simply projections, and again, I don't have time to go into great detail on this. There's the lower scenario basically means less CO2, less CO2 adding to the atmosphere and over the next 50 to 100 years, and the higher scenario is a greater increase of CO2 based on the same climate model and two different CO2 levels. Basically showing that this trend that we're seeing in heavy precipitation increases is not surprising, number one, and number two, that the models say it's going to continue, and that change depending upon how much, which scenario you pick. We're going to see a lot more of those types of events. And whether this is temperature or precipitation, we are more or less in this process moving the curve from left to right here. We're increasing, we can say hot weather, or we could say heavier precipitation. You could simply exchange those words in there and take out cold and hot and put wet and dry in there in terms of having more heavy precipitation. So we're basically moving the curve from, if you will, normal to the right, in this case, allowing the probability to increase for more heavy precipitation events. These are the outlooks for, sorry, not outlooks. These are the scenarios based on the 8.5 scenario, showing that winter and spring, at least in the north central part of the U.S., showing a pretty relatively strong agreement with some of the models in terms of increasing precipitation across that area. If you live in Alaska, there's a lot of agreement with the models in terms of more moisture, more precipitation in those areas. So putting this all into perspective, and then coming back and looking at the Missouri Basin, central part of the U.S., and these are some of the records that you can glean if you go into NCI's State of the Climate and such, Climate at a Glance. You can find all of this information in there. As of October of last year, nationally, not just the basins we're concerned with, not the Missouri Basin, we had the wettest 8, 9, etc., up to 5-year months on record across the country. That's pretty amazing, actually, with 125 years of record. Now, again, we're not talking about the Missouri Basin here, but I did want to pull this out because this is extremely important and really caught FEMA's eyes when this information was presented to them a month or two ago. You notice that the ranking from the top 10 ranking of the wettest years across the Midwest, and those are the Midwest states up there on the top, Minnesota to Ohio, okay, everything in between, 9 states. So if you average the precipitation over those states and then rank it in terms on an annual basis, you'll see that, you know, we have some of the major wet years in there. You'll recognize 93, for example. 2018, 2 years ago, was pretty wet. And then, of course, 2019 was the wettest when you take those 9 months. All that's interesting. But what's most interesting to me is the increments between each of the years is relatively small. When you're setting a record, you're setting a record a little bit. A few tenths, maybe a half an inch sometimes. What happens between 2018 and 2019? And this is what caught FEMA's eyes. We jump over 3 inches of rain. And that's 9 states. That's a lot of water. It's an incredible amount of water. Okay. I think Natalie's going to show this, so I won't talk too much about it. But here's 2018, the annual ranking of the states on the left, and 2019 on the right. Where you see 125 on the right, those are all records for all those states. Where you see 124, those are all records on the left. And notice it wasn't too shabby in the Midwest and basically plain states either year. Very wet 2 years. And then the graphic on the left there shows the same thing I showed a little bit earlier about the 9 states in each year, which is the wettest. But on the right is the 10-year period when you rank the Midwest. Again, we're not talking so much about the Missouri Basin here. I'm just sharing a little extra information that we have. Note, just go down the list there and look at the end year for each of the ranks there. 2019, 2018, 2017, 2016, 2015. That's 1, 2, 3, 4, 5 years in a row of a 10-year period, right? That set a record. I'd call that a trend. And if you look down below that, you see 11, 13, 14, 10. The only one that doesn't quite fit that is the 77 to 86 period. So that's pretty amazing. Also, when you take into account 2012 was part of that record. 2012 was an incredibly dry period during that. Here is the trend line, 5-year trend line for a 60-month period ending in December across the Missouri Basin. You see the 30s show up pretty nicely, the 50s show up pretty nicely in terms of drought. But then you have this sort of median period in the 60s and 70s. And then you see a lot more variability, and that variability is trending upward over time. All right, and again, based on the wettest 5 years, all of those basins that are darkest have their wettest 5-year wettest period, 2015 to 2019, ending in 2019, on record. Here's a core. This is from the Army Corps of Engineers, and this is showing annual average runoff at Sioux City or just above Sioux City, and their average is 25.3 million acre feet per year, right there. This is just showing you what it has looked like in the last, well, since about 1900, a little bit before that. And you can see there are periods of wet and dry, wet and dry, wet and dry, not really regular. Some people like to think that it's regular, but it's not. But there are dry periods in there, and there's some wet periods. But notice really the last, I don't know, 10, 15 years and how wet it has been and all the records that have been set. Okay, much different than almost any other time in the period of record before that. For those of you that are interested in the forecast for this year, 2020, and if we go back, you can see this year is their forecast, the red one here. It's going to be one of the higher years too. Excuse me. This basically, I'm not going to dwell on this too much, but you can have these later and look at it. Basically for runoff to be above normal for the rest of the year and such. A couple studies that were done on the Missouri Basin over the last 10 years after the 2011 flooding that we saw. There's a report, and if you go down, lower right corner is a bunch of fact sheets from NOAA's OER Esrel Physical Sciences Division. They've done some attribution studies. Excuse me. And in 2011, after the flooding in 2011, they said it was a pretty rare occurrence, low probability of reoccurrence in the immediate future. They did notice more volatile flow, in recent decades. 9 out of the 10 highest annual runoffs since 1970. Now, that was back then. Now it's been updated. I updated it for 12 of the last 13 highest annual runoffs since 1970 have occurred since 1970, I should say. And then the other thing was the increased year-to-year variability in annual runoff. Now, the people who wrote this are rethinking that first comment that I had up there, the rare occurrence of lower probability of rare occurrence of lower probability of reoccurrence in the immediate future after it happened again almost 2 years in a row. So they're going to work with the Corps of Engineers to kind of relook at those conclusions. Another study that was done by this similar group out there is that they found that flooding is the major contributing factor to one of the major contributing factors to flooding is cold season wetting. In other words, wetting up the soil profile, which increases the runoff efficiency, which is no surprise. The highest 4 runoff years since have happened since 1997. Warming is consistent with climate change theory, right? Continued warming will likely continue the trend of high runoff, but increased variability. So those are the findings from that report. Also in the same sort of area, if you want to go read more, there are full reports. These are little 2-pagers you can get the gist of. Anyway, there's more out there. And then here's the map of last year's disasters. Sorry. And you notice that there are some major flooding icons on there that denote some of the damage that was done. There's the trend in damage, and I think that's all I was going to say, except there is something new that I just found out yesterday from NCDC. If you're really interested in billion-dollar disasters by month, there's a new climatology that was done. So have fun with that too, and you can go down to NCI and pull that off if you really want to. Thank you all. And Natalie. Hopefully I did that fast enough.
Yeah, thanks, Doug. That was fast. So while I get my, here we go. Gonna get the slides up here real quick. So hopefully that is showing. Yeah, so good afternoon, everybody. Natalie Umflett here with the High Plains Regional Climate Center. We sit at the University of Nebraska in Lincoln. Doug did a great job providing us with some background information, trying to put some of what we've been seeing into some context. And now I'm going to delve into some specifics. So this presentation is really going to follow a lot of what's in the report. And so we will dive in. Simply put, 2019 was a year of extremes for the Missouri River Basin. So precipitation for the year was above 150% of normal across much of the region. You can see that here in this graphic on the left-hand side of the screen. So all that purple shading that you see in through here, that's all 150% of normal. And while the majority of the world experienced above normal temperatures, most of us here in the basin actually had below normal temperatures for the year. So you can see that here. It's really evident across portions of the northern tier of the basin, so Montana, North Dakota, South Dakota, even portions of Wyoming and Nebraska. So all of these areas had temperatures that were upwards of 3 degrees below normal. So we had a very wet and cool year overall. When we aggregate this up to the state level, we can see that this resulted in many states having their wettest or top 10 wettest year on record. So Doug briefly showed this map here on the left. So you can see our statewide precipitation ranks, of course, coming from NCEI. And so we can see that the wetness, of course, was not isolated to just the Missouri Basin, but also the Midwest and a lot of places out east. Also had states that were ranking very highly. And so we can see here over on the right-hand side, we can look at the statewide average temperatures. You can see those cooler conditions really concentrated in on the Missouri Basin. But one thing that we have to think about before we dive into 2019 is that we really have to look at 2018, especially the latter half of 2018, because that really helped to set the stage for what we experienced during the year. So 2018 was also a wet year, just to a little bit lesser degree. Heavy precipitation really started during the last half of the year, and the last 6 months were quite wet. So that's what we have here on the right-hand side of the screen. So this is showing our statewide precipitation ranks from July through December. And so Iowa had its wettest July to December, Kansas had a second, and Nebraska had its fifth. And so this precipitation, what happened was it led to saturated or nearly saturated soils for a large part of these states. I should also mention that these wet conditions were also prominent across southeastern part of South Dakota. And here in the plains, so for those of you who don't live in the plains, so once our ground freezes in the winter, any moisture that's in that soil is essentially locked in. And so this is really important for us for two reasons. So one, this creates an impervious surface. So any rain or melted snow that occurs over top of that frozen ground, it will not infiltrate into the ground. So it will just run off. And then two, once the ground unfreezes in the spring, this moisture isn't available for plants to use. So it's really locked in over the winter. And so these frozen soils, frozen saturated soils really were part of the key factors that occurred for 2019. So ultimately, by the end of 2018, there were a number of locations that had set new records for wettest year on record. And you can see that in the map here on the left. So we had about 50 stations in and near the Missouri Basin that had new records. And these stations all had at least 50 years worth of data. So we wanted to ensure they had some pretty long records there. I'll point out that one of these locations was Sioux Falls, South Dakota. So just located there in the southeast part of the state. So not only did they set a new record in 2018, but then the next year in 2019, they set another new record for wettest year on record. So we had lots of records even in 2018 across a wide part of the basin. We also need to take a look at the snowfall for the season. Snowfall did have a pretty important role to play in helping to kick off the flooding. So numerous locations across the region had a top 10 snowiest season. So this is stretching from July of 2018 through June of 2019. There are a few standout locations that I put here in this chart. Of course, there's many more. Since I live in Lincoln, I'm going to highlight that one. So we did have our snowiest season on record with over 55 inches. For context, that is about how much snow Minneapolis would get in a usual year. So their normals are just a little bit under that. And coming from a house that does not have a snowblower, I will tell you, it was a tough season. And that's a really big snow season for us here in southeastern Nebraska. And I should mention that for a lot of places, the snowiest month of the season was February. Okay, so these snowfall totals that I'm showing here is for the whole season, but for many places, the bulk of that fell in February, or February was their highest month. And so having the snow season, having the bulk of that snow come down in February, which was coupled with intense cold conditions that really allowed the snowpack to build and also allowed for thick ice to form in the rivers. So February really was very cold. It was one of the coldest on record for Montana, North Dakota, South Dakota, and Nebraska. All of these states ranked in the top 10 coldest. So Montana and North Dakota ranked second, coldest South Dakota was third, and Nebraska was eighth. Okay, so we had Frozen, so we had our frozen saturated soils, we had high snowpack with high snow water equivalent in place, we had frozen rivers, and then we had our bomb cyclone in March. And so what happened was that bomb cyclone, it brought a lot of warm air out in front of it, so we had a quick warm up, we had a big rain on snow event, and that led to some of the worst flooding that portions of eastern Nebraska, western Iowa, and southeastern South Dakota had ever experienced. But unfortunately, instead of the bomb cyclone being the big story for the year, that was not the end of our 2019 flooding. It really was only the beginning. So after this event, the precipitation just didn't stop. What's really interesting here to me is that it wasn't that every single month was record-breaking in 2019. But because we had such saturated soils and we had flooding already, the precipitation didn't have to be record-breaking to have big impacts. So what we were seeing was that even smaller events were causing a lot of issues. Of course, that's not to say there weren't other record-breaking months after March. There definitely were. So May 2019 was incredibly wet. So Kansas, Missouri, and Nebraska all had their wettest May on record. Kansas, though, is even more impressive. So that was their wettest month ever. So out of all the months since 1895, and it's something like 2,000 possible months, May of 2019 was the wettest on record for Kansas. So any way you slice it, these 2 years were incredibly wet and led to lots of issues across the region. So here we've got two different maps that I'm showing. So on the left-hand side, we've got 2019 precipitation records. So all of those red dots there. Again, it's a situation where these stations had at least 50 years worth of data. They have good records. And we've got somewhere around 175 different stations that set new records. And then if we combine 2018 and 2019 and look at every 2-year period of precipitation, you can see there on the right-hand side, we still have lots of records there. So it truly was an unprecedented 2-year period of wetness. So in all, moving on to flooding, there were about 75 record crests in the Missouri Basin. If you want more details about which locations that set records, you can see that on the USGS Water Watch website. It's a really great website. Not surprisingly, the majority of these records were set in the spring. Many of these were associated with the bomb cyclone event in March. But one thing that was really unusual was that there were several records that also occurred in the fall. And so these were not just little daily records or high flows. These were all-time records. So we had locations setting all-time record crests in the fall, beating out previous records that had occurred during either the spring or the summer months previously. And that's a really big deal because the fall, we're usually seeing our lower flows. We're heading into winter. Water's really, a lot of water has been evacuated from the system. And so seeing these records was really, really eye-opening, I thought. And so to give a little context here, so these records, these fall records were really isolated to eastern South Dakota. And this is where we had heavy rain and snow in the fall. And so that contributed to continued flooding. Okay, so there were already flooding conditions throughout the year, but then heavy rainfall and snow contributed to that. And so in this area, the flows were so high. So we had September runoff from the James, Vermilion, and Big Sioux rivers that was 16 times higher than average, and twice the previous record. So that is a lot of water. And speaking of runoff, so Doug had shown a few graphs earlier. So 2019 was the second highest runoff ever recorded for the Upper Basin, and only 2011 is higher. But the flooding that started in March, it really did persist. So it wasn't just persisting through South Dakota. Really throughout the basin, there was a lot of issues there. So we had many locations set new records for most number of consecutive days above flood stage. Many of these were along the main stem of the Missouri River in Nebraska and Missouri. So we had durations somewhere upwards of 270 days. And this flooding finally ended for these locations in early December from around the 6th through the 10th. So we had flooding throughout the majority of the year for these locations. But some locations, and this was along the James River in eastern South Dakota, did not drop below flood stage in the winter. They actually kept those flows were high all through the winter and only recently dropped below flood stage. And so you can see a few examples of those here. And so some of these places were upwards of a year above flood stage. So I was joking around earlier before we got the webinar started that we can't have a webinar about the Missouri Basin without at least one slide about drought. And so one thing that I thought was really interesting about the wetness was that, we did have this lack of drought. And you might be thinking, well, of course there's no drought. But for the Missouri Basin, which is a really large area, this was actually highly unusual. So on March 19th of 2019, the basin was free of drought for the first time since 2009. And this drought-free designation only lasted until April 9th. And that was when moderate drought conditions, so D1, that was introduced in north central Wyoming. But I did want to point out that other areas of the basin remain drought-free. And for Nebraska and South Dakota, this was the first time in the history of the U.S. Drought Monitor that these states were drought-free for an entire calendar year. So the wetness really continued and was long-lasting in those places. So we had all of this wetness, we had saturated soils, we had flooding. So what kind of impacts did all of this wetness have for the region? Honestly, we could write an entire book about what happened in 2019, and we would be writing it for a long time because the recovery is not complete. There are impacts that I'm sure will still be realized well into the future, and people are still rebuilding, and so the impacts are really far and wide. It's hard to tease out an exact figure in terms of cost for the basin, but if you take a look at the $1 billion weather and climate disasters page at NCEI, so what Doug showed earlier, the 2019 flooding, of course, caused significant losses. If you look at the March event alone, and this does cover a little bit more than just the Missouri Basin, because we did have flooding to the east of us, just outside the basin. So if you look at the March event alone, that is sitting at over $10 billion. And then if you look at subsequent events, there is another flooding event that's listed on their page. It includes, of course, more than the Missouri Basin, but that is also sitting at just over $6 billion. So we're looking at very big numbers. The region took a real big economic hit. And with everything that happened, it's not just the economy that we have to think about. The people of the region really did, the flooding really did take a toll on the people of the region. It's mentally very exhausting, considering what had happened. So agriculture, of course, took a big hit this past year. Conditions are really unfavorable for much of the growing season. Cool, wet weather throughout the year was not good for planting, harvesting, or overall crop development. So in the spring, of course, we had cool and wet conditions, and so planting and emergence were significantly delayed. Millions of acres were not planted. This was especially the case in South Dakota. But even when the crops went in, they were slow to mature because we had those cool, wet conditions into the summertime. Then at the start of the fall, you might remember, for anyone living in the basin, we had a little bit of a reprieve. I remember some days that were actually very hot. There was a new statewide high temperature record for Colorado, if anybody remembers that. So we did have a bit of a reprieve, but some areas, got hit really hard by some big snowstorms. And so northern areas of the basin across the Dakotas, they did have a lot of harvest issues because the fields were either covered in snow, they were muddy, or in some cases they were just completely inundated because these storms just kept hitting the area. Many producers actually couldn't get their crops out of the fields until this year, which is unusual. Of course, livestock, they endured harsh conditions in both the spring and the fall. Landowners also had a hard time. So this is especially those who were directly impacted by the floodwaters. So I'm thinking things like scouring, debris on the land. So the sheer amount of sand and debris on some fields was just incredible. In some cases, the cost of remediation far exceeded the value of the land, and that left a lot of landowners with difficult decisions to make. For ecosystems, there are a lot of mixed impacts. Luckily, the initial March flooding from the bomb cyclone occurred at a time where there were minimal impacts to wildlife, so a lot of migratory birds had not come into the region yet. In the long run, though, the flooding probably impacted many trees along the rivers. It can take about 2 to 5 years for trees to die from flooding, so we're not exactly sure what the impacts of those are yet. But a lot of these flooded areas also included state parks, recreation areas, wildlife areas. Those were forced to close, and so that took a hit on the recreation and tourism industry. Since people could not visit these places to enjoy them, they also had reduced revenue from those fees in these locations. There were some positives for ecosystems, so flooding does have a positive impact on a lot of wildlife in terms of creating habitats and things like that, so it wasn't all negative for wildlife. And of course, flooding caused a lot of damage to infrastructure, from dams and levees, roads, bridges, homes, businesses. It'll take quite some time to fully recover from these losses. And we do have some towns that are even considering relocating. If you want to see a really interesting case of that, I would look up Winslow, Nebraska. So they as a town are trying to decide if they would like to do it and if legally it is possible. Oh, and then I should mention here that the cool, wet conditions from last year did lead to an increase in energy demand. This was partly due to home heating needs, but also due to demand for propane to help with crop dry down in the fall. So lots of impacts. One slide does not do it justice. And who knows, maybe we'll write a report about this one day. So then just to kind of tie this back into what Doug was talking about, so how do we put all of this into context? How do we wrap our brains around what happened in 2019? So on its own, 2019 was the third wettest year on record for the basin. Okay, so here on the left-hand side, we have a graph from NCEI's Climate at a Glance, which I love. That website is fantastic. So this is just for the Missouri Basin. So just for that area, we're looking at annual precipitation through time from 1895 to present. And so 2019 was our third wettest year on record. Okay, so right over here. And what's interesting is this really isn't too far off in time from the third driest year on record, of course, 2012, which we all remember. And if we take these data and we aggregate into different time chunks, so we look at 2-year, 3-year, 4-year, 5-year time chunks, we see some really interesting things. So 2018-19 was the wettest 2-year time period. 2017 through 19 was the wettest 3-year time period. 2016 through 2019 was the second wettest 4-year time period. And 2015 to 2019 was the wettest 5-year time period. Now, keep in mind, what's so interesting about that is that a big portion of the region up in the north, up in the northern plains, had been experiencing drought through part of this time. So there was the big flash drought of 2017. So it's not that every single part of the basin was really wet all throughout that time period, but we did have, for these years to rank that highly, despite having drought in the region, is pretty interesting. So if we look at the trends through time, we can see here this blue line, that's our trend line. So we do have, precipitation generally increasing over time. If we break this down by season, we do have the strongest trends in the spring and the fall. This is about a 14% increase in those seasons. Of course, these trends aren't uniform over the whole basin. It's very large. We have our increases really occurring in the eastern areas of the region. Those are experiencing the largest increases. And then with an eye to the future, the fourth National Climate Assessment indicates that our precipitation in the basin is expected to increase, with the largest changes possible in the winter and the spring. So with that, I'd like to give a big thank you to the many partners that came together to make this report possible. whether that was contributing data or reviewing the report. There were many people across the region who contributed to the report's success. These are also listed in the report, so sorry this won't be up very long, but you can see all those folks in the report there. And if you want to learn more, here's a couple of links so that you can access the report directly. And also a report similar to ours was released for the Midwest, so it covers the extreme wetness and flooding just to our east in the Midwest region. So thanks again to all of our partners, all of you listening today, and thank you to my co-authors, Doug Cluck with NCEI and Dennis Toddy with the USDA Midwest Climate Hub. And with that, I will leave it to questions. Thank you.
Well, thank you so much, Natalie and Doug. That was great. And it's really amazing how exceptional the last couple of years were in your region. So on that, we're going to open it to questions. So again, if you have a question, please add it to the chat or you can raise your hand. And I'll start us off with a couple. So I'm wondering, you both talked a bit about trends, but were there any signs that 2018 and 2019 were going to be so exceptional for the Missouri River Basin? And also, we may have some participants in the webinar from other regions of the country. So I wonder if there's any words of wisdom you could share on what you've learned about how to communicate the historical nature of these events and their impacts.
So in terms of prediction of an extreme like this, I would venture to say no. In fact, some of the research, as I showed you earlier, sort of mentioned that it was very, very unlikely that a similar year to 2011 or anything like it would happen in the near future. So it's a tough call. You know, there's a couple things. So that's on the longer term. If you would ask me a year before 2018 or a year before 2019. However, you know, as Natalie mentioned, 2018 was so wet, and then the fall of 2018 was wet. Those are, when you see that, and that, you know, when we see that, all we know at that point is the risk is going up. We know the risk for flooding is going up. Now, when you start compounding it with a wet winter following a wet fall, and you compound it with frozen soil, and you compound it with colder than normal and a lot more snow, yeah, that in February, I think we were all saying, oh, you know, this could be a pretty bad flood year, but no way did we all ever say, oh, it's going to be an extreme year. So then all those sort of forces had to come together with the bomb cyclone, as Natalie mentioned, to sort of unleash or be the catalyst for the sort of unprecedented flooding that we saw. So you know, you know, talking to Kevin Lau at the River Forecast Center, Missouri Basin River Forecast Center, among others down there, you know, their models don't necessarily handle it when it gets that wet or that frozen, or we don't know what the runoff efficiency is going to be. We just know it's going to be more. So I guess that's what I'd say in terms of prediction stuff. We had an idea it was going to be bad, but not that bad.
Great. And Natalie, anything to add on the prediction, but also the communication of the sort of exceptional nature and impacts of these events?
Yeah, I think Doug really hit on the main points there with the prediction. Here in our region, in the fall, we always pay attention to precipitation and how that's impacting our soil moisture, because we know that's going to be locked in pretty much through the winter. So anytime we start to see saturated soils in the fall and early winter, we know that's something that we have to pay attention to. So I know that we all definitely had our eyes on what was happening at that time. I think from my point of view, and maybe Doug will agree, it was really February that you know, with that extreme cold and then snowstorm after snowstorm after snowstorm, that was really what tipped us off that we needed to be paying very close attention to what was going on. In terms of communication, we're really lucky here in the north central US because there are already a lot of resources out there to help get the word out, either before, during, or after an event like this. So Doug leads a series of webinars that occur the third Thursday of every month at 1 p.m. Central for anyone interested. So that provides a monthly view of the conditions that have been occurring, where we're at in the present, and then a look to the outlooks. The National Weather Service, of course, they've been holding different flood webinars to get the word out. So every month, a group of people come together to feed in information to these webinars. So it's not just the responsibility of one particular person to gather all that information. And that same sort of process came through for this report as well. So we had a lot of information to go off of with those webinars. Here at our center, we write a monthly and quarterly report of conditions as well. So, so having a lot of partners to work with, having them provide information and their point of view really helped to put this report together. And luckily, we have a lot of that infrastructure already in place. So putting this report together was a really good process of partnership.
I'll enhance that a little bit by saying that working with the ROC, the Regional Operations Center and Weather Service in Central Region, we were able to also put out pretty much post-flooding, to be honest, when conditions were already bad and more rain was coming, sort of at the, let's say, 8 to 14 day, we could see that the wetness was going to continue and there was fear of more heavy rains in certain places. We'd work with USDA and others to put together slideshows that the ROC would send out, I think, to all of you guys in the field, as well as some of the FEMA partners and state emergency management folks, and any other partners that they had on their list. And I would take those and send them to my list too. The participants on the webinars, I mean, it's grown over the years, but the participants on those monthly webinars are primarily not NOAA. In fact, they're usually state, federal, tribal governments, as well as a lot of business folks, mostly in the commodities side, some basic agriculture folks, banking, energy, navigation, those kinds of folks, and not NGOs, and of course academics too get on those calls. They're meant for layman. That's a layman's interpretation and translation of all of the stuff that NOAA puts out, part of our climate service portfolio of communication, I would argue.
Yeah, well, and thank you for advertising those. The regional climate briefings are terrific. So we did get one question from Scott Krasinski. How would this long duration, heavy rainfall and flooding period compare to the Great Flood of 1993 that impacted some of the same area?
Yeah. So, Natalie, I might have missed it. Did you have a slide with all of the records along the Missouri, or all those records Kevin Lau gave us in the Missouri Basin?
No, I don't have an image. It's in the report though.
Yeah. So basically, we set all kinds of new records in terms of peak flows, and they were impressive records. They weren't just barely making it over, which surprised a lot of folks because 2018 set a number of records. So there, in terms of duration, well, yeah, the duration part's really interesting too, because it started in March. We had incredible wetness in May. And I think, again, Natalie going to have to help me here. Again, in August and October, I mean, they were all super wet months. And it was not record, but it was just this continuation. And you already had everything all saturated. So there was no place for the water to go except for the streams runoff. So
that's great. Yeah.
Yeah,
So
there was Missouri and Mississippi Basin, of course, oriented too. And that's another discussion. We could talk about the Mississippi. That'd be a different talk. Go ahead. Sorry.
Oh yeah. So there. So I guess there were about 75 new all-time record crests in the region. So of course that would surpass 2011 and 1993. So that's quite a number of locations with their new record crests in 2019. And then we also had several locations, of course, that were up around 275 days of, continual above flood stage. And then in eastern South Dakota, we had locations that were over 300 days above flood stage. And these were all new records. So at least for these locations, this far surpassed 1993.
Okay, well, I think that's all the questions we had for today. So I wanted to thank Natalie and Doug again for their great presentations, and please follow the links to see their report. And thank you everyone for participating.